Hello students, before moving to the main topic, let us discuss something. In our daily life, we need many gadgets or appliances like video game, television, refrigerators, air conditioners, geysers, toasters. So what do we need to run these appliances? Yes, we need electricity. So in our day-to-day life, from the morning itself, when we wake up and went to the bathroom to take a shower, then we need a geyser. It will also run on the electricity. Then we came for a breakfast. Then also we need a toaster. We need a mixer grinder. Then these also run on the electricity. Then we need a cloth. It got iron by the electric press. So it also run on the electricity. So electricity plays a very important role in our life. Now, what is electricity? Actually, electricity, it is the flow of electrons. It is called electricity, or we can say the electric current. Now, what is electric current? So I have prepared some PPT. So let us focus on the topic. So today I am here with chapter number 12 of class 6, that is electricity and circuits. So let us focus on my PPT. Now, electricity and circuits. Now, topics to be covered are number 1. So today we will cover the following topics: introduction, electric current, electric cell, battery, bulb, torch, electric switches, conductors and insulators. So the objectives of the lesson is, at the end of the lesson you will be able to define electricity, establish the relationship between electric current and charges, list the uses of electricity, define electric cell, define battery, explain the construction and working of an electric bulb, electric torch, define electric switches and explain the conductors and insulators. So first is, what is electric current? The flow of electric charge constitutes electric current. It is measured by as the rate of flow of electric charge. The charge here is electron, and electron, it is a microscopic particle. So what is electron? I will tell you. Is made up of matter, or we can say anything which occupies space is a matter, and all the matter, it is made up of molecules. And matters, the states of matter are solid, liquid and gaseous. Let us take a liquid state, that is water. So it is made up of water molecules, that means hydrogen, one molecule of hydrogen and one atom of oxygen. Then these molecules are made up of atom, and in return this atom is made up of 3 tiny particles called proton, electron and neutron. Okay, so suppose this is the structure of atom. This is a nucleus. In this, proton plus neutrons are present, and in the shells electrons are revolving. Then these electrons helps in the conduction of electricity. Okay, these and the SI unit to measure the current is ampere. Like if we want to measure the length of a cloth, then we use the meter. If we want to measure the weight of a thing, then we use kg. Okay, similarly, if we want to measure the amount of the current flowing through a conductor, then we will use the unit ampere. Now it is measured by a device known as ammeter. This is a diagram. This is a ammeter. A, here it is written, shows that it is an ammeter. Here the wire will be connected, and the deflection of the needle shows the amount of the current flowing through the conductor. Next is different sources of electric current, from where we get the electric current. Suppose in our house we put on the switch and we have an electric current. Because there is a wiring in our house, we get the electric current from them. But sometimes when a power is gone, then we use the torch. So the electric current we get from the cell. Okay, so these are the different sources from where we get the electric current. These are the different kind of cells and the batteries. Now, what is the direction of the electric current? So direction of the electric current is from the positive to the negative terminal of the cell. I will tell you about the cell in the next slide. Okay, so this is how electric current will flow. The electric current will flow from the positive terminal to the negative terminal of the cells. Suppose this is a cell, this is the positive terminal of the cell, and this one is the negative terminal of the cell. Here the electric current will flow by the flow of the electrons. Okay, so electrons are the negatively charged particles, so they flow from the negative to the positive charge. Okay, so the direction of the electric current is just reverse of the flow of the electrons. So the direction of the current is from the positive to the negative terminal of the cell. Now these are the conditions needed for an electric current to flow. Number one, there must be a source of the electric current. Okay, here the source is cell. There must be a wire so that through this a current can be flow. And this is a bulb. It will show, when the bulb glows, it will show that the current is passing through the circuit. Okay, so it is not necessary that bulb should be connected, because when we connect this wire, then it will complete a circuit and the current will flows. Now next is electric cell. So when the power is gone, then we use the electric cell for a source of for the source of light. So what is cell? It is a simple device in which electrical energy is derived from the chemical reactions occur inside the cell, and it is a device which converts the chemical energy into the electrical energy. So it is a source of electricity. It has two terminals, positive and negative terminal. So carbon rod in the center constitutes the positive terminal, and the zinc contained is negative terminal. So usually it produces 1.5 volt of current. It has a zinc container, so it is negative terminal. So the power produced is here the current produces 1.5 volt. Now okay, this is a cell. So the upper portion, this knob, it will constitute a positive terminal, and here the base zinc portion, the metallic disc, it is a negative terminal of the cell. Here also it is written positive and negative terminal of the cell. Okay, so this is a cell. Now here this is a cell. If we see the internal structure of the cell, then we see this is the positive terminal. I have shown this. This is the insulator. The carbon rod is in the center, and here we have a mixture of manganese dioxide, and here it is a zinc cane. So this zinc cane constitutes the negative terminal, and it is a positive terminal. Now I will show you the internal structure of the cell. I have broken this cell to show you the internal structure of the cell. So this is a carbon rod inside it. So this carbon rod is a positive terminal and it is connected to this. Okay, so it has broken. So it is a positive terminal, or it is a carbon rod. Are you able to see? This is a carbon rod, and around this it has a black powder. This is a mixture of manganese dioxide. Okay, so it helps in conducting, and here at the base it has a zinc. Okay, so this is a negative terminal of the cell. So this is the internal structure of the cell. Okay, so I hope you understand the structure of the cell. Next, how the electricity is produced in the cell. So electricity is produced in the cell. An electric cell produces a small amount of electricity from the chemicals stored inside it. When the chemicals in the electric cells are used up, the electric cell stops producing electricity. That means I have shown you the black powdery mass. This is the chemical inside it, and this chemical in this powder the chemical reactions goes on, and these chemical reaction will produce the electric current, or we can say the electricity. And when the chemicals get exhausted or they get used up, then cells stops producing the electricity. Next is battery. Now what is battery? Battery. So battery is when two or more cells are joined together, then the combination is called a battery. So this is a single cell. Here it is positive terminal and this is negative terminal. And when the two cells join together like this, care should be taken that the opposite end of the cell should be connected. That means here the positive terminal and the negative terminal of one cell should be connected to the positive terminal of another cell, and it will, so that the current can flow. So here it is a two-celled battery, and similarly we can add on the cells and we can make three-celled battery, four-celled battery. Okay, now I will show you how we can prepare a battery. These are the two cells. Okay, so here it is written positive, here also it is written positive. So care should be taken that these two positive terminals should not be connected to each other. The positive terminal of one cell should be connected to the negative terminal of another cell. So it is a battery of two cells. Similarly, we can add on the cells. Like if we put another cell here, so it is a three-celled battery. So it will give a more power, or it will produce more electricity. So this is battery. Next is bulb. So what is bulb? Bulb is an electric bulb is a device which glows and emits light when the electric current is passed through it. In our home, when we put on the switch, when we see a bulb will glow, then there is a light in all over the room. So it will give out the light energy. When electric energy is passed through the bulb, it will give out the light and heat energy. So we get the light from a thin tiny wire inside the glass cover called filament. So here this is a small bulb, this is a filament. Okay, so it is supported by two thick wires. These are the two thick wires of the bulb. It is supported by two thick wires. The base of the bulb, this is the base of the bulb, and the metal tip of the base are the two terminals of the bulb. And here this is a metal tip. So this one, the base of the bulb, and metal tip of the bulb, these are the two terminals of the bulb. One may be positive and one may be negative. So these two thick wires connected with the terminals of the two different terminals of the bulb. Okay, so this is a electric bulb. It is used in the torch. So this is the base. This is one terminal, metal cap at the base. This is one terminal, and this is the base of the cell, and it will another terminal of the cell. These are the thick wires. Here the small tiny filament, you can see this is a filament which is connected to the two thick wires, and these two thick wires are connected to the two terminals of the bulb. Okay, the two thick wires are connected to each terminal, and the inside portion of the bulb is filled up with inert gases like argon. Here this bulb is filled with the inert gas like argons, because so that the filament cannot be rusted. Okay, it cannot be corroded. So I will show, I don't have a small bulb of a torch, so I will show you electric bulb here. This is an electric bulb. Here you can see a filament. Okay, when this filament is complete, then the current will pass through it and it will glow and heat up and gives up light. And these are the thick wires through which this filament is connected, and these wires are connected to the terminal of the cell. These are the terminal of the bulb. Okay, so this is a electric bulb. So this is a filament. When the filament get broken, then the circuit is also broken. So in this, the bulb will not glow, and we can say the bulb is fused. Okay. Now next is electric circuit. What is electric circuit? It is a closed path in which electric current can flow is called an electric circuit. So there are two kind of circuits. One is open circuit and another one is closed circuit. In open circuit, there is no flow of current. In closed circuit, current flows continuously. Here it is a diagram where the switch is in, this is closed circuit, so bulb will glow. This is open circuit, the connection is lost here, so bulb will not glow. So this is a diagram showing the open and closed circuit. Here this is a cell, the wire is connected to the bulb and another wire is also connected to the another terminal of the bulb, but this wire is not connected to the negative terminal of the bulb, so the circuit is broken here. So this is an open type of circuit because there is no complete the circuit is not complete. Okay, this is a closed circuit. Why? Because all two terminals of the cell get connected, so there is a flow of electricity in this circuit. So this is a closed circuit, so the bulb will glow. Now what is, let's have a definition of circuit. It is the complete path from one terminal of the electrical cell through the bulb and back to the other terminal of the electric cell is called a circuit. That means the current will flow from the one terminal, that is from positive terminal to the negative terminal of the cell. That means two terminal of the cell should be connected. Next, the types of circuit. One is open circuit. If there is any gap in the path of a circuit, the bulb does not light up. Such circuit is called an open circuit. Whereas in closed circuit, the bulb lights up when the bulb and wire from a complete path. Okay, in closed circuit, the bulb lights up when the bulb and wire form a complete path, which starts at one terminal of the electric cell and ends at the other terminal. Such a circuit is known as a closed circuit. So I will show you a circuit. I have two wires and a cell. I don't have a small bulb, so if I connect one wire at the positive terminal and another wire at negative terminal of the cell, if I connect these two wires, then the circuit gets closed. That means the flow of current will takes place. Okay, if I separated these two wires from each other, then the circuit becomes open and there is no flow of current. In between this, we can put a bulb also. So when the bulb will light up, it will show that there is a flow of electric current. Okay. These are the component of an electric circuits. Suppose if we want to draw an electric circuit, then we need more time because we have to draw the diagram of a bulb, we have to draw the diagram of the cell. So to make it convenient, we use the symbols of the electrical components of the electric circuits. So by using these symbols, we represent the electric circuit. Then this is called circuit diagram. So to draw the circuit diagram, we use the symbols of different electrical components. Like these are the symbols. This is the symbol of a cell. Okay, one big line and one is small line. Then this is a power supply. This is a symbol of wire, and bulb. This is a symbol of bulb, and this is a symbol of switch. So these are the symbols we can use to draw the circuit diagram of an electric circuit. Now, flow of current in a circuit. How the flow of current in a circuit takes place? I have told you earlier that the flow of electric current begins from positive and it will go towards the negative terminal. So the path from one terminal of electric cell to the other is completed. An electric current starts flowing through the circuit and the bulb lights up. The electric current flows from the positive terminal of the electric cell to its negative terminal. So from here it will go towards the negative terminal. This is the simple electric circuit. Here it is a battery, switch, light bulb and a wire. If we close the switch, then the circuit gets closed and the bulb will light up. If we open the switch, so bulb will not glow because the circuits get incomplete or the broken. So in the bulb, current enters through one terminal, flows through the filament inside the bulb and comes out through the other terminal of the bulb and when the current flows through the filament, it starts glowing. Okay. Now what is fused bulb? I have told you earlier that if the filament of the bulb is broken, the circuit is not completed and hence the current cannot flow. The bulb with broken filament is called a fused bulb, and when a bulb gets fused, it does not light up because the circuit gets incomplete. Okay. Now let us take these examples. In this circuit, the whole circuit is complete because positive terminal is connected to the one terminal of the cell and another terminal of the cell is connected to the negative terminal of the cell. So the circuit is closed. So bulb will glow. In this also, here the circuit is complete, but here the circuit is broken. So bulb will not glow in this condition. Similarly, in this condition, at the negative terminal, the circuit is complete, but at this terminal, positive terminal, the circuit is broken. So here also bulb will not glow. In this condition, the two terminals of the bulb is connected to the negative terminal of the cell. Both the terminals of the bulb is connected to the negative terminal of the cell. So here also the bulb will not glow. Similarly, here the two terminals of the bulb is connected to the positive terminal of the cell. So here also the bulb will not glow. But here this is a complete circuit. The positive terminal of the cell is connected to the one terminal of the bulb. Here the one terminal of the bulb is connected to the negative terminal of the cell. So here the circuit got completed and current takes place and bulb will glow. Now what are electric conductors and insulators? So conductors are the materials through which electric current can flow, are called conductors. So conductors are those materials which allow the electric current to pass through them. Suppose all the metals, most of the metals are the conductors. So our body is also a good conductor of the electricity. So care must be taken while handling the electrical appliances. Next is insulators. So insulators are those materials through which the electric current cannot pass. These are called the insulators. Insulators are the bad conductors of electricity, like rubber and wood are the insulators. Okay. Prepared a one electric circuit. Here there is a combination of two cells. So it is a battery. So here it is a switch and it is a wire with lots of LEDs. Okay. So when I put switch in on position, these LED will glow up. That means the circuit is closed here. So current can pass through this circuit. When I switch off this, that means the circuit gets broken. That means the circuit is open now. So here the electricity cannot flow. So okay students, if in place of this switch, if I put this plastic, okay, that means between the terminal of the cell and the wire, if I put this plastic, then the electricity will not flow because this is a insulator. Okay. But if instead of this switch, if I put this spoon, because it is metallic, so if I put this spoon, then the circuit got complete because through this spoon the electricity can pass through it because it is a conductor. So this is a conductor, this is an insulator. Similarly, this pen is made up of plastic, this is also an insulator. Okay. So this safety pin, it is made up of metal, it is a conductor. This hairpin, this is made up of metal and this is also a conductor. Okay students. Conduction test. It is a simple device to test whether a material is conductor or insulator. I have told this ki if I put, this is a safety pin, if I put another material like plastic material, then the circuit it is not completed, it gets broken, so the bulb will not glow. If I put the safety pin here, so the circuit got completed because electricity can pass through the conductor, so it will glow. Now electric switch. So electric switch is a simple device that either breaks the circuit or complete it to stop the flow of the current. When the switch completes the circuit, it is called closed switch, and when the switch breaks the circuit, it is called open switch. Here in this circuit also, this is a switch. If it gets in on position, these LED will lit up. Okay, so circuit got complete. If I put it off, then the circuit gets broken. Okay, so electric switch, we use electric switches to put on or off the electrical devices and machines. So an electric switch is a device that is used to open or close an electric circuit. Here the switch is connected. This is open switch because it is off position. In off position, the circuit gets open and bulb will not glow because the currents cannot pass through the circuit. Here it is a closed switch. Okay, closed switch, that means it is in on position, current get passed through the circuit and bulb will glow. So I will show you a switch which we use in our house. So this is a switch which we use in our house. So I have connected these LEDs here. So this switch is in off position. So when I put this switch in on position, these LED will glow. That means the circuit in this house or in this wire gets connected. The circuit get closed and current will pass through the circuit and these will glow. When I put it in off position, then the circuit gets broken and these gets put off. So the last topic is torch. So what is torch? If we do not have a power supply in our house, then to lit the room we use the torch, and in the torch we use the electrical energy of the cells. So torch, it is made up of a cylindrical or cubical casing. The casing can be metallic or non-metallic. The cells are kept inside the casing. This is a case. So the cells are kept inside the casing. It has a spring which is attached to the metallic wire. This is a metallic wire. Okay. The spring helps in keeping the cells snugly fit in the place. Okay. The spring helps these cells to keep in one place. The metallic wire is attached to a switch. The switch is then attached to the negative terminal of the holder. The positive end of the holder touches the positive terminal of the cell at the bottom. The bulb fits inside the holder. So this is a whole torch. Now I will show you a torch. So students, this is a torch. This is a switch of a torch. Okay, now I will show you a whole structure of this torch. When I open this torch, here you will see a reflector of a torch. It will reflect the light. I am using the LED torch. Okay, so here these are the terminals. Next, this is a plastic casing, and inside the plastic casing, these are the cell holders. Here the cells are kept in place, and inside the torch you can see a spring and a wire. Okay, which is attached to the switch. Here you can see a metallic plate which is attached to the switch. So when I put the switch in on or in off position, this metallic plate will connect or disconnect the connection from the cell. Okay, so I have fitted all the components of the torch. Now if I put the switch on, it will glow. Okay, if I put the switch off, then it will not glow because the connection get lost. Okay, so this is a torch. This is how it works. Now I will show you this diagram which will show the structure of the torch. I have shown this. This is a bulb. This is a reflector. Okay, this is a plastic casing. This is a slide switch, and these are the cells, and here it is a spring. So this is a metallic wire through which the switch the switch will, and this is a wire through which this switch will complete or break the circuit. Okay, so this is all for today. So we have completed the chapter 12, that is electricity and circuits. Thank you.